recording?
Yeah.
Okay, go ahead and read.
8-point charges plus cubes sit at the corners of a cube of side A. What is the potential at the center of the cube? What is the potential at the center of the cube base and at the center of the cube edge?
Okay, so I have a cube and I have 8-point charges. Each of these charges is at the corner of a cube, and they all have the same size, right?
Mm-hmm.
They're all cubes.
Yes.
And I have to find what the potential is at the very, very middle of this. So inside of the box. What's in the box?
Nothing.
Anybody seen that movie?
Yeah.
No.
What movie?
7.
7. You're not allowed to watch it anymore, right?
Really?
Yeah. You know who's in it? Who's in 7?
Brad Pitt.
Brad Pitt. Yeah, that's fine.
Gwyneth
Paltrow, that's fine.
Morgan Freeman.
Morgan Freeman, that's fine. He's still acceptable.
He's
You?
a legend.
Who's me? I'm not in it. Who is unacceptable? Who's the bad guy?
Kevin Spacey.
Kevin Spacey.
Yeah, that's
Can't watch Kevin Spacey
Yeah.
anymore. He killed that movie. Why can't you watch Kevin Spacey?
Who's that?
Who's that? Oh, you don't want to know. Be happy in your ignorance. He's an awful human being. Okay, so we have our box with the 8 charges, and we want to know what the potential is at the middle of the box. So somewhere like right there at the very center. Yeah? Right at the middle. So to get the potential due to a system of point charges, you have to take the potential of all the point charges and add them all together. Yep. So that's what we need to do. To figure out what the potential is of all these 8-point charges, we need to know the general equation for potential due to a point charge. What is the equation for potential of a charge? E equals K times the charge, whatever that charge is, divided by R, which is the position, the distance between the charge and where you want to know the potential. Yep. So I want to know what is the potential for all these corners of this cube at the center of this box. To figure that out, I have to take this formula, take this equation, plug it in for each one of the corners. So I'll pick this corner up here. I have to know the magnitude, V. I have to know the magnitude of the charge Q. I have to know K, and I have to know the distance. The distance is the key in this problem, knowing the distance from the different places. So from one corner to the middle of the box, we need to know how far that is. So I have to get from this back corner into the middle of the box. To do that, I need to do something called adding in quadrature. So adding in quadrature is basically a way to do 3-dimensional triangle adding. So first, I'm going to imagine that this isn't a box. I'm going to just imagine that it's a square. We'll use a side that doesn't have something written on it. So I'm going to get from this corner to the middle of the box. So first, I'm going to go down some certain distance. I'm going to get to the halfway point because I'm trying to get to the middle of the whole box. How far is it from the top corner to the middle?
A over 2.
That's A over 2. Okay. A over 2. Is this visual actually helping?
Yes.
A over 2.
Yes.
Yeah? Now I still want to get to the middle of the box, so I have to kind of move to the middle.
A over 2.
Right? So that's another A over 2. Okay. Am I in the middle of the box yet?
No. You're in the middle of the face.
No, I'm in the middle of a face. I need to get to the middle of the box. So now I need to get, and I can imagine I'm at the middle of the box, but I need to get from here to the exact middle. How far from here to the exact middle?
A over 2.
That's another A over 2. Yeah? Another A over 2.
So yeah, run that past mine.
So A over 2 to get here, A over 2 to get here, and then I need to get inside of the box. So I have to go another down. Yeah. So that's another.
Were you in the middle of the box after the third
A over 2. Well, yeah, this is the same one that we were doing. So I'm doing A over 2, and then down A over 2.
Yeah.
So that's X, Y, and Z.
Right.
They're all going different directions. I can't just add them up normally. I have to add them up like they're right pieces of a right triangle, right? Because I am doing this arc at an angle. I'm going from the back of this box, way back here, to the middle. So I'm doing a diagonal. Yep. Yep, I've got multiple diagonals here. To add things in diagonals, it's called adding in quadrature. So I do a over 2 squared plus a over 2 squared plus a over 2 squared. Square root of that gets me the radius to get from the corner to the middle. Yeah? Does that make sense?
Yeah.
Yeah? Okay, so what does that equation look like?
So then a over 2 squared plus a over 2 squared plus a over 2. That's it.
Looks like v equals k times q divided by a over 2 squared plus a over 2 squared plus a over 2 squared square root. Yeah? Okay, what's the next part say?
What is the potential of this side? Wait. What is the potential at the center of a cube face?
What is the potential at the center of a cube face? So that means I want the potential right there at that position. Yeah. This one, was this our full potential for before? That's the potential from one charge. What's the potential from the second charge? Same thing. Same thing from all corners, so we multiply that by 8. Yeah. We can follow a similar process to do this, to do the center of this face. So I want to get from this corner, and I want to get to the middle. So that's drawing a straight diagonal. Yeah. Straight diagonal across this face.
Can you show me again?
So I want to get from here to the middle of the face.
Yeah.
To do that, I go down a over 2, I go a over 2,
Okay.
and that gives me that diagonal right there.
Okay.
Yeah?
Mm-hmm.
So how big is that diagonal?
A over 2. This a over 2 squared plus a over 2 squared is the square root of that.
Yep. So that's x squared plus y squared gives me z squared. A squared plus b squared is c squared. So I add these in quadrature again. I get some k times q divided by a over 2 squared plus a over 2 squared. We want to make sure we put those in parentheses because it's the whole quantity a over 2 that's squared. So that's to get from this corner to the middle. How about from this corner to the middle?
The same thing.
Same thing? You sure?
No.
I'm going to get from here to the middle. I go down. How far did I go down? A over 2. How far did I go over? A over 2. So I've got 2 of those. How about from the bottom? Same thing? Up a over 2 and over a over?
Yeah.
Crap, I got 3. What? 4? Why didn't you say that sooner? 4. Do I have 5?
No.
Where's the 5th corner?
From the back of the box.
It's from the back of the box. So now I have to get to the front of the box, and then I have to get to the middle. So I know I'm going to have this a over 2 and this a over 2, but first I have to get up to here.
Okay.
Yeah? So I've got plus this other back charge is going to be a pain in the butt. I have to go from the back up to the front. How far is that? That's a full A. That's an A squared. That's all of our grades on the next exam. And then I need to get to the middle. So that's a over 2 squared plus a over 2 squared. Yeah? Okay, so that's from this back corner. How about from this back corner?
Same.
A over 2, A over 2. How about from this bottom back corner? A over 2, A over 2. This back corner? Same thing. So same thing from all the back corners, so that's 4. That's an important thing to note. I have 8 corners for this cube, so I need 8 different charges. Here I have 8 times q. Here I have 4q, so I know I have another 4 charges, 4q. Gives me my total 8q. What's the last part of this?
Oh, sorry. It's the center of the edge.
Center of the edge. So I have to get, what's the potential right here at the middle of this edge? Yeah? Let's do this corner. How far to get from this corner to the center?
A over half.
That's half the distance of the whole side of the square, so that's a over 2. Do I have to do anything with the square roots or squaring anything? No, that's a straight up distance that I'm traveling. I am traveling along that line. So that's KQ divided by A over 2. How about this corner? Same thing, A over 2. So that's 2 of those. Okay, how about from that corner?
A times A over 2.
So I have to go up A, and then I have to go over A over 2. So I am coming along this diagonal.
Oh,
If I'm going along a diagonal, what do I have to do? Pythagorean Theorem. So I have to do what's called adding in quadrature. I have to go up A. You can think of that like your x squared plus y squared gives me the z squared. Yep. So that's got to be A squared to get up to the top, and then A over 2 to get over. Square root of that, and that's K times Q. So that's from the bottom of this up to here. Now I have to get from this bottom corner. I have to go up A over 2. So that's another one of those. That's the same thing, right? So I have 2 of those. How many charges do I have? I'm up to 4 charges. How many more charges do I need?
4.
4 more charges. I have to come to the back corners. Okay. So I'm going to get from this back corner to this center of this edge. How do I get there? I have to go down. How far down is that?
A.
That's A, and then I have to go over
A over 2.
A over 2. So that's the same as this, isn't it?
Yeah.
So that means I have 3 of those.
That means you're going to have 4.
That means you're going to have 4, because I still have to go down and then over from this corner. So that gives me 4 of those. How many more charges?
2.
2 more charges. I need to find these 2 corners. So I need to get from here to the middle of this. Yeah? To get there, I need to move over A, I need to move up A, and then I need to move in A over 2. Yeah? We'll show you that again. So that's K times Q. I need to move up A towards the front, then up A towards the top, and then over A over 2. So that's got to be A squared plus A squared plus A over 2 quantity squared. And then how about from this back corner of the box? I still need to get up to the front, so I need to go to the front of the box is A, to the top of the box is A, to the middle of the box is A over 2. Same thing, that gives me 2. How many charges? 1, 2, plus 4 is 6, plus 2 is 8. 8 charges, I'm all set. Any questions? No? Yes?